Hey guys, Mr. Catlin here. Last page of your homework, lesson 12. Let's knock it out. We've got a cookie recipe that uses 3 cups of flour to make 15 cookies. How many cookies can you make with this recipe with 4 cups? Assume you have enough of all of the other ingredients. Okay, so this is just a proportional relationship. We've got flour to cookies. 3 cups of flour makes 15 cookies. Thus, 4 cups, because of the constant of proportionality being 5, will make 20 cookies, assuming that everything is the same there. And I know that just because I knew that I could multiply 3 times 5 to get 15, so that relationship is true for whatever number of cups of flour I have. It should grow at the same rate for making the same cookie. All right, and then the next problem there is a teacher uses 36 centimeters of tape to hang up 9 projects for students. And at this rate, how much tape would the teacher need to hang up 10? Okay, so this is another pretty easy one here. We've got centimeters versus students. Those are our quantities. And 36 is enough for 9. And I noticed that this has a constant of proportionality of a quarter, right? A quarter of that number will be here. So if I want to do 10 students, then instead of multiplying by a quarter to go this way, I could multiply by its reciprocal and come back. And the reciprocal of 1/4 is 4. Or I could divide by a quarter, same thing. Either way, that's 40. So the relationship there is times 4 in the reverse, if you want to think of it that way, and times a quarter in the constant of proportionality. So I would be able to hang up, I need 40 centimeters of tape to hang up for 10 students. Okay, evaluate the expression when the answer is not a whole number. Write your answer as a fraction. Okay, so the ones that we don't get whole, we're going to have to write it as a fraction. That's pretty easy. So let's do part A right here. -4 times a -6. We have learned that a negative times a negative is a positive. And 4 times 6 is 24. So pretty easy start for us there. Let's do part B right here. -24 times, let's put it over 1 because we're multiplying it by a fraction, times -7/6. Okay, negative times a negative, we're going to get a positive. So we know that. If we look at our diagonals, nothing with the 1 and the 7, but we can take the 24 and the 6 and reduce that down to a common factor of 6 here. So 1 and 6 goes into that 4. So 4 times 7 is 28. And 1 times 1 is 1. So our answer there is just a regular old 28, positive. All right, let's do C right here. 4 divided by a -6. All right, so a positive divided by a negative. We know we're going to get a negative out of this because the signs are different. And we just need to do 4 divided by 6, which I think is easier to think of in fraction form. So 4 divided by 6 is really just a fraction we can reduce with a common factor of 2. 2 goes into that 4 twice, and 2 goes into the 6 3 times. So we get -2/3 for that particular one. 4/6 is 2/3, but negative in this case. And then lastly, let's do D. We got 4/3 divided by a -24. And when we're dividing numbers that have fractions involved, it's probably good for us to write them both in fraction form. 4/3 divided by a -24/1. And then to help us get this in the right form, we want to change it from division to multiplication by the second number's reciprocal. So that would be the same as 4/3, keep, change, and then flip to -1/24. And a negative times a positive is negative, so we know this is going to be negative. And then when we go through here and we look at our diagonals, 4 goes into this once and 4 goes into that 6 times. So this comes out to be -1/18. So -1/18 for D. And that finishes up number 2. To move on down. Number 3. So number 3, we have these boats that are traveling up a river. So I'm going to do a vertical number line for this. Here's my river. and up and down a river. So this is up north, this is south. The satellite is recording the movements of several boats. We have a motorboat that traveled negative 3.4 miles per hour for 7,500 hours. How far did it go? Okay, so here's 0, and it's negative, so it's going down the river this way. And it's skip jumping by 3.4s and every hour. But this doesn't travel for an entire hour. So it would be at 3.4 in an hour, but we want to know where it would be after 0.75 hours. So maybe a better idea to do this problem would be to set up a table instead of a number line, since we got the decimals. Let's do that. We got hours and we got miles. We got 75 hundredths of an hour and negative. Hold on. We don't know how far it goes, so we don't know the miles, but we do know that the constant of proportionality for this boat is negative 3.4. Well, that makes this easier. I know it's a constant because it says miles per hour. It's a speed. It doesn't say miles as by itself because that would have gone here. But since it relates the two, it's the constant. So I can just multiply 3.4 times 0.75 and get that answer. And since it's a positive times a negative, it's going to be down on the river, right? So negative of that 0 point. So we just got to do 3.4 times 0.75. That's not too bad. 20, carry the 2. 15, add the 2. 0. 28. 7 and 3 is 21, plus 2 is 23. And then add 0, 15, carry the 1, 4, 5, and 2. 1, 2, 3 decimal moves. So boom, boom, boom. 2.55, but of course it is negative. So negative 2.55 miles is our answer there. And it's negative because it was going down the river. We got a tugboat that traveled negative 1.5 miles in 0.3 hours. This one wants to know its velocity, so let's make a quick little table for it. Here's the hours, here's the miles, and the hours are 0.3, and the miles are negative 1.5. This one actually wants to know what speed it was, what was the constant of proportionality. So you just needed to divide negative 1.5 by positive 0.3. Negative divided by positive. This is going to be a negative velocity, so it's going down the river. And when you divide, we're going to move our decimal over and think of this as 3 into 15 and have our decimal point there. So that's just 5. And of course, it's negative, so negative 5 miles per hour. Easy enough. What do you think that negative distances and velocities could mean in this situation? I think negative just means that it's going maybe down the river, maybe downstream or south. So maybe negative is down either stream or south, possibly. It's just moving the opposite direction of the current, or maybe it's a north-south kind of thing. Could be lots of different things, but there's got to be a reference point for them. It might be a reference point around like a checkpoint or something. Let's look at the last question. We've got a submarine, and it's only allowed to change its depth by rising toward the surface in 60-meter stages. Okay, so 60-meter stages, and it starts off at negative 340, and we want to know its depth after 1, 2, and 4 stages. All right, so changing its depth and it's rising toward the surface. So let's draw what's happening here. Here's the surface of the water up here. We will call it 0. And we have this submarine down here at negative 340. All right, this is my best submarine drawing right here. You guys are going to be blown away by how awesome it is. Look at that submarine. Look at that. It's at negative 340. That was so horrible. The worst submarine in the history of submarines, but there it is. It looks like a poorly drawn foot of a cartoon character. That's what I'm going with. It's 340 meters below the surface, and it can only jump in 60-meter increments. So It's moving by 60s, right? Skip jumping by 60s. And we want to know what is its depth after these stages. So really, this is multiplication, 60 times 1. It's going to go 60 up higher, right? 60 times 2, it's going to go 120 higher. 60 times 4, that's going to go 200 feet higher. But you could also think of this as 60 going into this negative 340 and telling you like where you're ending, right? So you could also think of it as 340 dividing into the about 60 to tell us how many it's going to take to get to the surface, especially for this last question. So if I went up 60 from there, this would be like negative 280 for the first stage, right? So the first stage, I would be at negative 280 because I went up 60. And then 2 stages up from there, that'd be another, 60, that'd be negative 220. So that's where it would be after 2 stages. And then 4 stages, 240 from there would be at like negative 100, which would be roughly about here, right? Because I'm adding up 240 from there. So that one would be negative 100. But if I want to know how many it's going to take to get to the surface, I'm essentially doing negative 340 divided by these 60 stages, right? And so 60 going into that, it won't go into 334. So we got to do the 340. And I know that 60 times 5 is 300. So I'm going to do that, 5. And I'm going to have a remainder, right? I got 40 left over. So 5 and 40/60ths, or 5 and 4/6, or 5 and 2/3. So it's going to take 5 and 2/3 of a stage, but you're not going to do this. You can only do these stages one at a time. You can't do a fraction of one. So 5 would leave you just a little bit below the surface, and then the 6th one will get you to the top. So we're going to say that it would take 6 stages to get up there. Just, boom, 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 boom. We know that 4 gets you really close. 5th one's going to get you 60 higher, which is going to be at negative 40, right? And then you got that 6th one to finish off those last 40 meters. And that's your homework, guys. That gets you through everything. You should be caught up and hopefully get that done by Friday. Good luck on your quiz when you take it.